Okay, we're back. This time I'm going to do something again having to do with projectile motion, but particularly showing the independence of what happens in the X plane versus what happens in the Y plane. When we learned about projectile motion in physics, we learned that when an object is thrown, let's say to the side, in the X direction, gravity does not act. Only air friction would affect the X direction, but if we ignore the effects of air friction, gravity's effects are not felt in the X direction, only in the Y. So in the Y direction, the velocity is going to be reduced over time. So it's going to go like something like this, but the X direction is always going to stay the same, the X direction velocity. So now the question comes something like this. What if you were to take two balls and you were to just throw one of them to the side with a zero angle, just horizontally, with some initial velocity, and the other one you were to just drop it. So V initial is 0. Which one would hit the ground first? Okay. This is a classic question asked of beginning physics students. Okay. You know what the classic example of the classic answer is? The classic answer is that most students say this one hits the ground first. It has a shorter distance to go. Okay? Or some students might say, well, it depends how fast this one is shot. Maybe if it's a bullet, it goes very fast. Okay? Or maybe some students say it depends on the height. If it's a short height, one of them will hit the ground first. If it's a big height, one of the other ones will hit the ground first. So we get variety of answers. But it ends up that they hit the ground at the same time. They should hit the ground at the same time because the initial velocity in the Y direction, right? In the Y direction, what's the initial velocity of both balls? 0, right? V initial Y is 0. No, none of the balls is thrown down or thrown up. This one is just thrown sideways, right? So as far as gravity is concerned, their Y direction velocities are both 0, so the gravity acts on them similarly, and the Y direction equations for both of them are the same. The only difference is this guy is going sideways, so they should both hit the ground at the same time. But since this guy has a velocity in the X direction, the distance that it travels in the X direction is going to be V initial t. This guy is just thrown down, just dropped from rest, so the distance that it should travel in the X direction is 0, you see? So according to physics, this one should just drop, it should not travel in the X direction. This one should travel a certain distance depending on the velocity, but they should both hit the ground at the same time. So let's try this one here. We have this mechanism here. We got this ball on the right, and then we got this other ball. When I release this, this is going to shoot that out, and it's going to hit the ground. And then when I release this, this one is just simply going to drop. Okay? And what we're going to do is we're going to show you two views. One, we want you to just see that, and we want you to listen for the two balls hitting the ground at the same time. Just listen for the sound. And then next, we'll actually show you the videotape of the ground, and then you'll see that they will hit the ground at the same time. So listen for this one now. Okay? So that one, you probably heard it. They did hit the ground at the same time. And now, the camera is gonna zoom in on the ground part and try to catch this whole region here. And now hopefully you will actually see this visually, that they will hit the ground at the same time. Okay, so now you see that they actually do hit. Now, doesn't matter what the velocity of this had been. I could shoot a bullet straight, and it's going to hit the ground at the same time, but of course it's going to travel a much further distance. Okay, thank you.